Hey Evie, how are you? I'm good, thanks. By the way, I forgot to answer your question, but yeah, I'm okay. How are you? Good to hear. Good to hear. Do you guys have to come in on the strike day for the? In my school, the year 11s have to come in anyway. But last maths mock this week. Okay, how have they gone so far? Nice. Am I gonna change? One and two defo 70 plus. I'd say 78. Damn! Smashed it. You have your results. So they've already marked and gave you back paper 1 and 2. But they haven't. You haven't even done the third one. Huh. Your school is extremely efficient. Damn, that's really quick. Not bad though. I'm glad you're confident. Are you saving it to like look at your overall grade? How comes? I mean, look. If you're doing 70 plus, like, I mean, you're going to be completely fine. It's definitely grade 9. You want 80. It's good you have that ambition. It's good, really good. See, now I'm like curious, really curious, to see exactly what you've got. So if you get 80 on any one of the papers, you'll be happy, right? Like paper 1, 2, or 3. Ah. So you got... No. Oh, wait. So... Wow. So you got 79 out of 80 on that? Evie! Oh, in your head. Right, I see. Oh... That's really frustrating, man. That is so... It's always the small things, though. It's always the easy questions. Yeah, I get you now, yeah. Mm-hmm. And it was a quadratic, okay. Yeah. Or x plus 15 squared. But yeah, that's the same thing. Yeah, if that's the only solution, then yeah. 100%. 100%. Oh, man. But it's always the small things that you mess up on. Ah, nice one. Yeah, it's one of those like not tricky questions, but it's one of those questions that kind of catch you off guard. Like if there's only one solution, like what that means. Had a good circle theorem question. Good to hear. Circle theorems people tend to mess up on, so they like to put them in there. Faux show. Actually, that is a. You reminded me of something I can look at. Like alternate angles and isosceles, proving those like 90 minus. Oh, I think I've seen that question. Yeah, 90 minus a half x. Yeah, I've actually seen that. So that's I know, right? Not bad. Okay, it sounds like it went really well. If those are like the really big questions. A, B, and C lie on a straight line. Calculate the size of PBQ. That could be interesting. Okay. Okay, so we can get started then with this. So basically what I found is a few more like tricky questions. So the first thing we haven't really gone through yet is algebraic fractions, which is what these are. And so we're going to do a couple of these. Some of them are a bit tricky. You know, they might catch you off guard. And then I have some other questions that I found that are difficult. But I also have some more questions that are difficult, if that makes sense. So they kind of, yeah, I've basically got a bunch of difficult questions after these algebraic fractions. But I wanted to make sure that everyone's okay with this, because they can be a bit tricky sometimes. So what I'll do with this question is, first things first, we can write the same thing again. But when we divide fractions, all we do is we flip them. As in we flip the second one and make it multiply. So multiply, and then that'd be x squared minus 4x over 2x squared plus 9x plus 10. I will say that the number of marks here I think are a bit low, because you have to factorize like 2 quadratics, so it's a bit more in depth. But for this one, hopefully it should be fairly okay. You can factorize an x out of the x squared minus 4x, so let's do that. And if you let me know if this is getting too easy, then we will go on to something else. But I have some other kind of questions we can do. And we want two numbers that multiply to 20 and to 9. So that would be 5 and 4. So 2x squared. Yeah? Okay. Let me show you a different type of question then, just to see if that works. What about something like this? Have you done like ratios with quadratics like this? Not quadratics, with algebra? Okay, so let's go on to some of the exam questions that I thought might be, again, not necessarily difficult, but some that are kind of neglected sometimes. So for example, with this one, describe fully the single transformation that maps A onto B. My approach for this is always to think, okay, eliminate them. So our different transformations are translation, you have enlargement, you have reflection, you have rotation, and that's it. Yeah. Okay. So what is it in this case? But A was a reflection and B was the rotation. Interesting. Okay. Yeah, so these are the four we have. So the first one I can tick off is it's definitely not translation. Translation is just when you move a shape left, right, up and down. So as we can see, it's flipped upside down, so it can't be that. Okay. Now here's where things might get a bit tricky. Right? The exact position, yeah. Oh, okay, yeah. It's a bit tricky. Could it be a rotation? Well, maybe. Could it be a rotation? Reflection or enlargement. So this one is, in my opinion, a bit tricky. Let me make sure. So it could be a reflection. Sorry, rotation. Yeah. Okay. So we'll keep that in mind. Could it be a reflection? I don't think so, right? So far are we in agreement? Yeah. And wait, could it be a reflection? I mean, I guess, okay, so if I look at this, if I say, okay, it could be a reflection, I see what you mean. So it says one transformation. You are right. If you reflected it twice, you could do it. Yeah, so it just says the single transformation. So if they say single, it needs to be one transformation. As in, you can't reflect twice, right? Does that make sense? Rotation? It could also be an enlargement. And this is why I thought this question was a bit tricky, right? So if you said that this was a rotation, right? If you say rotation, there are a few different components. You need to say rotation, that's 1 mark. But you also need to say how many degrees and what direction. Yes, now you're seeing, Evie. I am of the opinion that it's actually an enlargement by -1. And the reason, how I can tell is I can work out a centre of enlargement by joining the coordinates together, right? Okay, it should be a straight line, but hopefully you can see my point. And they all cross here. So here's where your 3 marks comes from. You say enlargement. And that's what I thought, that one was a bit tricky, right? So that's 1 mark. By scale factor. So the scale factor here might be a bit tricky. It's the same size, so we know it's 1. But since it's upside down, it's -1. Okay, that's all you need to do. So that's another mark. And then you need to say what the centre is, and the centre in this case is 0,1. So that's your 3rd mark. So I thought that was a bit tricky because normally if it's an enlargement, they make it obvious by making it bigger or smaller. But in this one, they actually kind of, threw a bit of a curveball, a little bit. Yeah, so it's a bit of a tricky. I want to say it's like more like you could have easily got this wrong. So the rotation one, the reason why I didn't see that is there isn't actually any way you could put the center of rotation where it would rotate on top of each other. Okay. This one, I think Evie, you're the only one here, so I'm not sure if you'll struggle with this one, to be honest. But we can definitely have a look. So with part A, what do you think ABD is? ABD is, it's not quite 90. The 90 thing is potentially correct. 180 minus 400, more minus 35 minus 90. I think you're thinking a bit too far, a bit too deep. So that'd be 135. So you think it's 35? Okay. So it's not quite 35. And I know this question. I know this is what I'm saying. I found questions that I thought were like a bit. They kind of throw a curveball at you. Why can't you do DEB? That's where you got that from, I see. That works with... Okay, hold on. Let's see if we get the same answer. This is what I thought it was, and we'll see if we get the same answer. So, you know when you have a diameter, that's the same as just having 2 is the radius, right? So this whole angle here is 90 degrees because it's a tangent and a radius. So your answer would just be 90 minus 35, which is what you said. So what you said is fine. Sorry, I think I added it wrong. My bad. Yeah, that is correct. So 45 degrees. Not 45. 55 degrees. Good lord. Basic math hard. So why can't you do DEB instead alternate? Wait, that's not what you got, is it? But it should be 180 minus 90 minus 35. Yeah. So you're correct. You can do it your way as well. But does my way make sense? And again, if anyone else has joined as well, just let me know if it makes sense or not. The circle theorem I used is that because they told me this is the diameter. Yeah. 55, yeah, perfect spirits, well done. Yeah, cool. So I thought that was a bit of a tricksy one that they kind of throw there. And then the last one, it says, find the size of the angle DEB. So, yeah, I hope so. last lesson you were telling me the basic methods. Now at least I'm showing you some basic ones. So okay, find the find the size of the angle DEB. So that is this angle here, which, I mean, you kind of already worked out. So you can use kind of Evie's method. If there's a circle theorem that says that if you have a diameter of the circle and you create a triangle from it, it's exactly, you kill two birds with one stone. You actually get a right angle like this. Okay? So the circle theorem just says if you have the diameter and you create a triangle from the end points of the diameter, right? So one side is the diameter of the triangle, of the circle. You'll always get a right angle triangle. So once again, you can just do 180 minus 90 minus 35, which you should notice is the exact same answer, which I think is a bit cruel, because that might confuse you in an exam if you get two answers that are the same. You could have also used use Evie's logic but backwards. So because you know that this is 55, alternate angle theorem will mean that this is also 55 degrees. Right? So you have a bunch of different ways to work that out. Okay, I think that's pretty good so far. Okay. This is the last question that I found that was quite interesting. I found some others that are quite good, and I have to keep kind of finding some more. So we have 4 containers, water is poured into each container at a constant rate. And here are 4 graphs, and they show you how the depth of the water in each container changes with time. And you need to basically say match each graph with the correct container. So, fairly interesting, I think. And this is all to do with the actual shape. Okay, so remember, with the depth, if it's narrow, so for example, if you had like a cone, something like this, right? My lovely drawing right there. At the bottom of the cone, the depth is going to increase really, really quickly, right? Because it's very narrow. Okay, so as it gets wider, the depth will increase at a slower rate. Okay, so let's see what Evie said. Evie said 3, 2, 4, 1. Okay, I haven't verified this just yet. But let's have a think. So yeah, I would actually start with kind of the shape that I was most familiar with. So, which is, I don't know if Evie did that. But if I look at this cylinder here, the actual width of it stays the same the whole time, which means the depth should increase at a constant rate, which means B is with number 2, for sure. So we're done with this one, and we're done with this one. Perfect. After that, this can get a bit tricky, so what I would have a look at is 3 looks like the most complicated, so I'd leave that until last. So if I look at number 1, that looks like my cone, right? Except that it has a flat base instead of a ice cream cone. Okay. I think it's actually called a fulcrum or something like that. Anyways. So it's going to start off increasing quickly and then slow down over time. Right? Should that make sense? Which means, so which graph shows that it's going to start very quick, like increasing quickly, and then slow down over time? That's D. So 1 is D. So I'll cross that one out. If any of you are unsure, then just let me know, and we can. I can go through it in a bit more detail. Out of 3 and 4, I think that 4 is probably the slightly easier one to go through, potentially. Perfect. Again, this one starts off a bit narrow, and it gets wider, and then it gets narrow again. So we're looking for basically slow, fast, and then slow again. So that's A, right? Because it starts off slow, and then it speeds up, and then it slows down again. And that's because it goes out like that. So that is going to be, so C is going to be 4. Perfect. And now that leaves me with the last one, but I don't need to actually work it out. I can just write 3, because it has to be 3. You okay, Evie? Yeah, you got it right, yeah. And again, if you want to check your answer, it's quite good to just, okay, even though you know 3 is A, well, let's have a look. Does it make sense? Well, it should start off kind of normal, and then it should speed up because it gets narrower, and then slow down. So speed up and then slow down. So it's basically the inverse of the C graph. Okay. So, I need to copy over some more questions. Give me 1 second. So I found this 7 marker, which would be interesting to say. So something like this. I'm going to give you a few seconds just to have a look at it and to go through it. And this is a calculator paper, by the way, just in case you are interested. Is it? Fair enough if you think it's chill. Paper 2. Oh, yeah. If you give me 2 seconds, I'm just getting the next question ready, and then I'll... So I go live for GCSEs. I go live every single Tuesday at 6 PM. And yeah, it's every single week so far, anyways. Wait, is this correct? Oh, that's foundation tier. Oh god, that was stupid. Okay. No worries. Sorry, I'm just... There's one thing that's popped up. I just need to check it quickly. Okay, let's go. So, with this one, yeah, Evie, you're correct. Correct? You're right. So what you want to do here is if you're working out the angle PBQ, that is this angle right here. So what you need to do is somehow, what I would do personally, is try and work out these two angles and then use the fact that the angles on a straight line add up to 180 degrees. So the question is, how do we work those out? Evie's given us a bit of a hint. You can use the sine rule on this one because, so why can we use the sine rule? Well, we have an angle and its opposite side, and we have a side. So we can work out its opposite angle by using the sine rule. So we can use sine A over A equals sine B over B. So in this case, I can label that this is A, that's capital A, this is capital B, and that's lowercase b. Okay? But keep in mind, it doesn't actually matter what you label. The only important thing is that the A and A need to be opposite angle sides. Okay, that's the only thing that matters in this question. And other than that, the letters don't really make much of a difference. So you have sine 72 over 7.5 is equal to sine B over 4.1. So then sine B is just equal to... That does say sine, believe me, even though I kind of wrote sim. 4.1 sine 72 over 7.5. By the way, if you have any questions that you want me to go through now, please let me know. If there are any topics you want me to go through, please let me know. Given that we've done so much work already, like we've done so many topics and so many different exam questions, I'm kind of running out of things to teach you guys. So please let me know. I personally can't, Evie, no. I personally can't. I'm sorry if that disappoints you. Oh yeah, there is a way. Yeah. 100% there's a way. They used to, right? Like, we've been doing trigonometry for thousands of years. So that there is a way. Basically, yeah, you can actually work it out exactly. So the way you do it, if I remember rightly... Oh, I'm in radians again, one sec. If I remember correctly, is... these triangles actually make up part of a circle, and you basically just use the ratios of the sides. So there's definitely a way to do it, yeah. Yeah, radians, yuck, indeed. I don't know why it defaults to radians every time I open up this calculator, but you know. And that's 31.3 degrees. Wait, have you already worked it out, Spirits? Okay, I'll speed up a little bit. And then here we're going to use the cosine rule. So the cosine rule, we're going to use the fact that this is A. B and C doesn't matter which way around you put them. But the cosine rule, as we all know, A squared is equal to B squared plus C squared minus 2bc cos A. So if you were to rearrange it for the angle, you would get... And let me know if you want me to actually show you how to rearrange this fairly easily. I wouldn't bother memorizing it because it's really not bad to calculate it. So that is... Again, it doesn't really matter which way around B and C are. 2 squared minus 8.6. But you don't need to memorize it, Evie. Fair enough. If your memory works well, then that's great. But my memory is shockingly bad, so I need to rely on calculations. That is sad, actually, and that's surprising. Normally they always put something like that in there, because algebra tends to be a bit weak for students of your level. Tends to be. 2 function questions. Functions aren't too bad, are they? Or do we need to kind of go back through them a little bit? Wait, have I made a mistake? They're easy. Oh, you wanted more, I see. You won't get many more than 2 function questions. I promise you that. B squared plus C squared, yeah. You'd also like more functions? Okay. Yeah. So inverse cos is 9 to 1.5. In coordinates. So if you put an x and y axis when they only ask for x, you should always put a y axis if you have an x axis, right? 100% of the time. But yeah, I can't imagine why you wouldn't give that. Like, he was asking for the x-intercept. Oh. So they were asking for, like, the solutions, right? Like, the actual coordinate. It depends how they worded it. If they said, what's the roots of the equation or the solutions of the equation, then you have to just write x. If they said, like, the coordinates, then you'll be fine writing the y-coordinate as well. I hope that makes sense. And then, yeah, you need to add to the nearest. So, yeah. Then you should be okay. But it depends on your teachers. That's the problem. Because at the school I teach at, some teachers are really, really anal about it. Like, they're very specific. And it says to the nearest degrees, that's 57 degrees. Okay. So, apparently you guys found that easier than I thought. So, I'm going to have to whip out the big guns. I think this one's actually... Yeah, this would be fun. These are actual GCSE questions. It's just that I had to dig them up from the dredges of... Yeah, but it just depends on the teacher, I think, at that point. I would personally give it because I know what you mean, but other teachers are less forgiving than I am. So what about this question? This one should be pretty tricky, I'm hoping. This is easy. Really? Surely not, right? Exactly. I haven't even read the damn thing. Really? Fair enough. It's kind of annoying, but that is fair enough. This is all okay, alright. I'm literally finding questions as I'm going through, by the way, so I do apologise for the tardiness of it. You still haven't quite... Evie, I don't think that's... You know what? Next year you're doing A-level maths, right? We'll do the A-level math streams, right, which are on Thursday, by the way. And there are questions that will potentially make you cry on that. But you're too good at GCSE maths. I don't know if it's possible for me to make you cry on GCSE maths, to be honest. Okay. It's very... Okay. But yeah, it's... I don't think it's possible with you, to be honest. Let's hope. You're a bit of a masochist, you know that, right? Okay. So, first of all, this is a hard question. So, if we read it, it tells me that AM is equal to MB and OP is perpendicular to this line as well, right? Which should make sense because chords are always perpendicular to the radius of a circle. God, don't know why that took so long. So it tells me that AB is 20.8, which means either side of this should be 10.4, right? And it tells me that MP here is 1.5. Okay. Now how to explain this in a fairly easy way. The total radius, right? Let's call the radius R. Sausage triangle. Interesting. So I'm going to call this is R. This is R. For Mo. Yeah, so this side here is R minus 1.5. The reason why it's R is because from O to P is the radius, but M to P is 1.5. So yeah, Pythagoras for R. Okay, well done. So you can make it one kind of big triangle. So R squared. If you use Pythagoras, the hypotenuse R squared is equal to 10.4 squared, the bottom bit, plus R minus 1.5 squared. So I'm using Pythagoras. So if I draw out the triangle that I'm using, O, M, and B, this here is 10.4. This side is R minus 1.5, and this is just R. I hope that makes sense. And then from here, all you're doing essentially is expanding and rearranging for R, and then it's a quadratic equation, which should be okay. Yeah, and it's 6 marks, so I don't think it's too bad. For this, you can do that, yeah? So yeah, R squared. But why can't you use two radiuses to make and call this 45? Let me think what you're saying. So using these two radiuses, and what do you mean by call this 45? Like, as in this is 45 degrees? Like this angle at O or the angle at A? Wait, OAP. So this angle here. OAP and AOP. Yeah? Yeah, because it's an isosceles triangle. You can do that. That is correct as well. Why can't you use two radiuses to make an isosceles triangle? Yeah, you can do that. So, as Evie pointed out, if you have these two radii here, they're obviously going to make an isosceles triangle, because these are the radiuses of the circle. So yeah, you can use that as well. Shortcut it a little bit. Yeah. In 10? I don't know. I like my way. Of course I like my way, but I like my way. I'll leave it as 10.4 squared for now, because this is going to be a bit messy, I think. Plus R squared minus 3R. Wait, hang on a minute. Wait, you're saying these two angles are the same? But these two lengths aren't the same, right? For that to happen, A to M and M to O would have to be the same, right? Yeah. So for this triangle to be isosceles, wouldn't you have to have the same... Two of the sides would have to be the same. OA and OB. Oh, I see what you mean now. So you're talking about using the entire triangle itself. But OB... So OA and OB are the same. Yeah, so these two angles are the same. That's correct. So the angle at A and the angle at B are the same. That's correct. But how do you know they're 45? Like, at this point, you'd have a triangle that looks like this. Where that's R. That's R. So this is O. A. And that's 20.8. Why not? Because in isosceles triangles, like, these two angles are the same, but they don't have to be 45, right? Surely that makes a right angle. Bold of you to assume, Evie. But why would it make a right angle? OAB. This angle here. I'm confused. So this angle here, why is this angle not a right angle? Okay. It's not really a case of it not being a right angle. It's like, but how can you know it's a right angle? It might look like one, but all they've done is taken 2 points on the circumference of the circle. You can't assume that it's a right angle. Right? Unless I'm missing something, but I don't think I am. Jeez. Okay. Poor Edexcel. It actually isn't an Edexcel question. But, yeah. So, okay, continuing on. You can cancel out the r squareds from both sides. So now you have 0 is equal to... And I'm actually going to move the 3r to the other side, because that makes me happy. So we have 3r equals 10.4 squared minus 2.25. So r is just equal to 10.4 squared minus 2.25 over tree. This is actually the Welsh exam board. You want me to do it by hand? To do it by hand? I think you overestimate how much... I mean, look at that number. 35.3 centimeters. Okay. Really? You trust yourself more than a calculator? I aspire to that level of confidence. That's easy. That's easy. Wow. I really do respect that. Like, I'm not even kidding. Well, these questions are all easy. Ooh, okay. So yeah, I think Evie, you're the only one here now, but assuming if anyone else is there, that's fine. So what would you like to do with the rest of... So we have about 9-10 weeks. I can't remember the exact date. It's about 10 weeks until your first maths paper. What would you like to do for the next 10 lessons? Because I'm kind of running out, I'm not going to lie. Oh, you said stat stuff, didn't you? Okay. We'll do that next week. We'll do all the stats stuff next week. In fact, you know what I'll do? I'll actually make the lesson right now. I'll just be like, stats. Because there is actually some nuance to that. like in terms of like what distributions and what sampling methods you need and things like that, which you might not have done. Yeah, that's fine. We'll do that next week, 100,000%. Is there any questions you have now about the stats? Because I'm assuming your last paper is paper 3. For box plot, yeah. If you're lacking... No. Wait, for interquartile range, then yeah. For interquartile range, it's the upper quartile minus the lower quartile. Yeah, that's fine. Like drawing? What do you mean by IQRS? Is that interquartile range? For drawing it, you have to include the median, 100%. Yeah? Why'd you do that? So, like with the interquartile range, you always take the upper quartile minus the lower. So you don't discard the median. So like for example, in your thing, we had 2, 2. Yeah? Yeah, like plotting it, okay. Yeah. Yeah, like drawing. So when you're drawing the box plot, right? To work out the lower. Oh, crap. Okay, I see what you mean. Like, have they given you the interquartile range? You need to work out the lower one. So they give you, like, you see what the width is, yeah, and you need to work it out. Okay. Yeah, so with this is Q1. That's Q2, that's Q3. So yeah, oh, I see what you mean now. Okay. I'm baffled about this question. Hello. You need to draw the whole thing. Yeah, so did it give you a list of numbers like this? Yeah. You know what? Let me see if I can find some questions on it quickly. I think I see what you mean. Yeah, so when you're drawing it, so median was like number 10. Yeah, okay. You don't discard the median to work out the lower quartile. Yeah, you don't get rid of the number 10. No. You have to leave them all there. So, was it something similar to this question? I'm just going to pull it over quickly. I know it might be an easier question, but like, I'm assuming it was something similar to this. Like that. It's fine if you're... Yeah, so when you work out the quartiles, you always leave the numbers like there still. Yeah, so the thing you're plotting... I did like the 2.5. Yeah. Okay. So the things you're plotting are just the lowest value, the highest value, and then the quartile. So if I were working it out, I'd write lowest is 48. Highest is 91, that's fairly easy. And then if you're working out the lower quartile, for example, you're doing a quarter of the values. So that's 11 over 4. So you can do 11 plus 1 over 4, which would be the third value, so that's 56. So Q1 is equal to 56. Then when I'm working out the next value, I keep them in there. Okay. And yeah, so with the Q2, you do the exact same thing. So 11 plus 1 over 2. So 6. You still count the 59. So 1, 2, 3, 4, 5, 6. So in this case, 69. And then again with the Q3. This one's a bit tricky, so you do 3 over 4 times 12, which is 9. So you look for the 9th value. So 1, 2, 3, 80. I mean, it depends what you mean by discarded, right? Like, yeah. Like when you said discarded, like let's say if I got rid of this number, right? If I didn't count it when I'm doing the median, so 1, 2, 3, 4, 5, 6, I would get a different number. So it kind of depends on if you did that or not. And then, so after you got rid of 69, yeah, so the problem with that is that, like, let's say, so for this one, it was the 9th value, right? So if I do the same thing, I do 1, 2, 3, 4, 5, and then I'd skip that 6, 7, 8, 9. I would get 81 instead. Oh. Oh. I see. You work it out differently. So when you worked out the 3rd value, you just looked at these numbers. Yeah, I see what you mean. Yeah, I see. So you just looked at these numbers, but since it's an even number of numbers, you got rid of 69, which gave you 59 as the middle. Yeah, you should be okay. You should be alright. I thought you were doing the same method that I do. That should be fine. Should be. Yeah, I see what you mean now. So you split it in half and you work it out like that. Okay, fair enough. Interesting. So yeah, we'll definitely do stats next week. I mean, honestly, 78's bloody great, honestly. Definitely. Did you say you might do like further maths A level? There's a proof question expanding double brackets. Okay. Interesting, yeah. I'm sure there'll be some stuff that'll make you cry in that then. But no, you are exceptionally good at maths. It's always the small mistakes that will get you. Honestly. To be honest, I would forget about it. Okay, yeah. Minus 15. Crap. Yeah. I feel like you put a lot of pressure on yourself. Yeah. I think you put a lot of pressure on yourself. Like, you know when you said that you wanted to get 18, you'd be annoyed if you didn't. That's kind of... It's unneeded pressure. If you can relax, it'll avoid making small mistakes. But I get that it's hard to relax, right? Like, just saying, lol, just relax is ridiculous. You need to find some techniques to, like, calm yourself down a bit. But, again, like, these minor mistakes, it's not the end of the world, but I do get that it's going to be annoying. Yeah, hopefully. I think it will be. It's normally like a really weird smattering of different topics too, which is kind of funny. Do you want to see the Actually, there's a question I want to show you. The ones they gave us have been easy, yeah. Do you know if they were like a certain year? Or did they just kind of make up their own question? By the way, hey Bucket, how are you? It's a locked one, so it's probably the 2022 papers, yeah. Locked practice. Oh, locked practice ones, yeah. Okay, that makes sense. With this question, by the way, something that's quite interesting is it looks really simple, right? But a lot of people got this wrong. Like, a lot of people got this wrong. And it would be interesting to see if you guys will make the same mistake. So what you're saying is that the arc length, is this correct? So arc length is equal to 16 centimeters. So then what you do is you'd have, what, like half 2 pi r equals 16? And then work out the radius and then work out the area. Is that what you think you need to do? There we are. Nice one. This is actually incorrect. So if you were to draw this out, so you have like this shape here, the total distance all the way around is 16 centimeters. Fair enough. So I thought the arc was the trick. No, actually, it's actually the diameter. That's the trick. Fair enough, if you think it's common sense, not bad. So yeah, in this case, you have the arc length plus twice the radius. So if you, or we can call it the diameter. I think I'll prefer to call it radius just for this case. So this would be 2 times the radius, and then yeah, you have the arc length. So in terms of arc length, the way you'd work that out is just a half times 2 pi r, and then that's plus 2r equals 16. So pi r plus 2r, whoops, is equal to 16. And then you can work out r from there by factorising out an r. Plus 2. And then you can just use the area as just a half pi r squared for a semicircle. Yeah? Yeah. Oh, nice. Those are like fairly high, like a fairly high number of marks too, if I remember rightly. So it's good that you got that and you've practiced it a lot. That's what that maths is really, especially at this level. It's just practice. Where they gave you a list of numbers. Hold on, let me read that in 1 second. So yeah, the answer for that one would have just been 15.2. Okay. Centimeters squared. Okay, so can you help? There's a question. I don't know what year, but they gave you. What exam board are you? That will help me narrow it down. But they gave you a list of numbers, and then on it they had a and b as the variable. They gave us the median, mean, mode. Interesting. If you let me know what exam board you are, I can probably try and scan for it. But if anyone else remembers the question, then that would be quite useful to go through. AQA. Evie, do you recognise that question? Maths facts in my head. What do you mean by maths facts? Just like random facts about maths that you find interesting. Wait, who? The other person? Oh, the ones that will help. S minus 2 times 180. Oh, like those little equations that we had. Crap. Trivia. Oh my god. You really put me on the spot. More than equations. So just so YouTube team guy. This is a GCSE maths question, right? If you have a higher median, they perform better. Oh, okay. Oh, crap. Give me a sec. I'm going to look through a bunch of paper 3s, and it might help me find the mean median mode. Yeah, like comparing is a GCSE question. Alright. I'll try and find it. I'm not 100% sure. Like, you know when you asked me to make up the question, I'm not 100% sure what it would look like. Like, I'll have to know what the data is first in order to make it up. Give you a list of numbers, and then on it they had A and B as a variable. So in the list of numbers they had A and B, and they told you what the median, mean, and mode is, and you need to find A and B. The worst thing is, I feel like I remember. I'm trying to find it. Okay, wait, hang on. GCSE AQA maths mean median mode find. Mean median mode. Hang on, we could. Okay. Alright. Yeah, so some other facts in terms of like the range and everything. What I could do is show you like a little comparison between. I think that's what he was talking about, yeah, but then he started saying some like other random stuff, so I that removed. Okay. Okay, so discrete data. Okay, there we are. Yeah, this is the GCSE stats, by the way. I don't think you do GCSE stats, so you don't have to worry about it, but it has some stuff from normal GCSE maths. So continuous data, actually, okay, discrete, it means it only takes specific values. So for example, shoe sizes, right? In general, they take specific numbers. So like size 1, size 1.5, size 2, 2.5, 3, 3.5. There's very specific numbers, right? Continuous data can take any value you like. So for example, someone's height could be, it could be 177.358 centimeters or something like that. That's the only difference. So discrete has specific set values. So again, things like shoe size or something like that, or even like dress size as well. Like it has specific values. And continuous data can take any kind of range of values. Does that make a bit of sense? It should also be noted that... Did I explain it well? Does that make any... What are the basic shape stuff? What do you mean basic shape stuff? Like tick boxes. Oh God, man. Oh, so like facts about trapeziums and stuff. Oh, okay. I can help you out with that. Okay, so with trapeziums, the interesting thing is that two of the sides are going to be parallel to each other. So it might be the kind of top and bottom or the sideways. There is a kind of logical way that you can work it out. Right? So you have these two parallel lines. With all trapeziums, you have two parallel lines. Normally it's the top and bottom one, okay? Now the reason why this is interesting is you can use C angles, co-interior angles. Because the thing about trapeziums is that these two angles here and also these two angles here add up to 180. We want to talk about parallel lines and the total angle thing. Yeah, exactly. So in terms of a logical way, is if you realise and remember that they have what other shapes, you can also have parallelograms. You're just going to have to trust me that that's a parallelogram. And here you can also use the co-interior angles, right? So these two angles here, so again, A and B, C and D. I was a thick child and never learnt the basic stuff. Look, trust me, just split the shapes into triangles if it's more than 4 lines or a quadrilateral and a triangle. Honestly, I was actually the reverse. I was very smart as a kid and I got dumb as I got into a teenager. Yeah. I mean, yeah, exactly. I was a thick child at 16, so... I see. Okay. You might want to work on that. The thing is, you'll learn it very quickly because it is quite like a basic thing. But with decimal multiplication, you need to get rid of the decimal. So, for example, if you're doing like 10.4 times 2.3, yeah. So if you were doing like 10.4 times 2.3, you can't multiply them using the normal column method, realistically. What you have to do instead, or what you should do, is get rid of the decimals, right? And then add them back in at the end. That's the better way to do it. So what I mean by that is you do... Yeah, that's what you're supposed to do, Evie. That's what you're supposed to do. Technically speaking. I know, but you actually are meant to do it that way. So, it's you shouldn't fear making mistakes. It's okay. Mistakes are just part of it. If I'm being completely honest, if I did the GCSE exam now, I wouldn't get 100% because I'd make a dumb mistake. You guys have seen me make dumb mistakes. I know it. I know the actual content, but I make mistakes too. Exactly. It's better to start dumb and end up intelligent rather than starting intelligent and ending up dumb. That's a tragedy. That's a fall from grace. Okay, so for next week then, what we'll do is we will definitely do some... Okay. Where are we? Who are we? We're here. Okay. Okay, so what I'll do is, this is the stuff for next week, so we're going to do stats. And then we're also going to do, so, really confusing, it's mock paper 2021. And then Edexcel. Mock paper. Okay. If it's a mock paper, I might have to get it from when I'm at school. Mock set 6. I believe in you, Evie. You can get 75 plus. I'm praying. Okay. So, give me one second. I'm going to look it up quickly, Bucket. So, Edexcel mock paper set 6. You said 2021, right? Yeah, 2021. Yeah, that's fair enough, Bucket. The thing is, are you sure that your school didn't make them? Because Edexcel doesn't really provide, like, mock sets. Was it the student room? Wait, hang on, I might have said something stupid. Yeah, I think I may have just found it. Okay. So it's 2021 paper 2 higher. Wait, paper 2's not... Was it a calculator paper or non-calculator Bucket? Wait, never mind. I might be being stupid. Okay, hang on. Okay, set 6 isn't on here. Let's have a look. It's calculator. All right. This is on another page. Set 6. Okay. 2H. But this is a practice test. Sorry, was it practice or was it mock for sure? No, it's fine, it's fine. Wait, let me show you what I'm looking at right now. So these are all of them. So set 6 is like down here. Was it practice or mock? Do you remember? I suppose we just open up this. Question 19. Okay, that's definitely not it, right? Damn, okay. The thing is, your school may have made it themselves. That's the problem. Because the mock papers are... Hang on a minute. They said mock a second ago. I'm sure it did. Yeah, I'm really sorry. I mean, there's 200 papers here. I don't know. I don't... Set 16. Good lord. Alright. Yeah, sure. I'll put it in the chat. No worries. You should be able to access this. Yeah. To be fair, I don't actually think that this is a thing. To be fair, Bucket, if you want, I can send you my email and you can send a picture of it. But oh god, my hand's so shaky. All right. You okay, Evie? Yeah, 200 and something papers. I mean, if they're tricky, then maybe we can go through some of them as well as a... Yeah, I am interested, for sure. But... Oh, wait, hold on. Oh my goodness. Wait, Bucket, is this it? Oh my god. Alright, I'm gonna put this in the... Oh my lord. I can't believe I found that. I'm actually gobsmacked. Alright. Okay, let's have a look-see at it. Oh god, which page was that? Yeah, it's this one. Okay, cool. I've never seen this question before, so if I get it wrong, I do apologise. And let's go over to this. Okay, so at the start of the day, n, the number of cells being tested is Tn. Okay, that's fine. And at the start of the next day, the number of cells being used in the experiment is Tn plus 1, where Tn plus 1 is Ktn, and K is a positive constant. Given that... I know, detective mode, man. Sherlock Holmes. I deduced. What is this? Marvin, that's a very good question. Basically, Edexcel, turns out, releases mock papers that are kind of strange questions that they get given. And this is an iteration question. It's a 5 marker. And yeah, other than that, I actually don't know what this is. I've never seen this question before in my life, so it should be fun. So they give us a few different outlooks. Oh, I see. Okay, I know exactly what we need to do. I believe. To find the value of m. Okay. Intriguing. So T1 is the initial. Okay, so what we're going to have to do here is essentially we're going to have to use simultaneous equations. I'm almost 100% certain. And good lord, okay. So T1 is 250,000. That is the initial day. Did you forget? Okay, so T2, I don't know what the value is, but it's just going to equal 250,000 K. Yeah, Evie, I'm not reading that number, just so you're aware. And therefore T3 is going to equal 250,000 K times K. Oh, okay, I see. Okay, I see. And because T3 is 490,000, we have 490,000 equals... I've never really seen a 5-mark iteration question. 250,000 K squared. So yeah, Evie's right, so K is going to just be... I don't know if this was a non-calculator paper, but let's have a look. We can cross out all 4 of these zeros, which makes it 49 over 25. So K is just equal to square root 49 over 25. Oh, it's calculator, of course it is, never mind. Which is 7 over 5. Yeah, literally, of course it's calculator, it's paper 2. My bad. Okay. And then it just says that T7 to T4 is m to 1, so all we need to do is work out the value of T4 and T7. So the way I do iteration, so our equation at the moment is going to be Tn plus 1 equals 7 over 5 Tn. I know, right, Evie? This is actually a really interesting question. The way I do it is I type in my initial amount, which is 250,000, and I press equals. So now it's the A and S button. And then all I do is I do 7 over 5. Yeah, I mean, this... To be fair, the only reason why I knew to do this is I just wrote down the information in terms of the equation, and then the answer came to me. Right? I didn't actually have to... I didn't know what to do until I started reading the question and started, like, going through it in my head. So what I recommend is if you've come across a question that's really difficult, is write out the information they give you in terms of equations, and generally you can see what you have to do. Generally. So T2 is 250,000. Yep, that's fine. T3 is 490,000, as we know. T4 is 686,000, so let's write that one down. The way I know it's 4 is because I know I've pressed equals 4 times. Right, and then the next one I want to work out is 7, so... T5 is 960,400, T6, and lastly T7, which is 108. No, it's not. It's 1,882,000. 1 million. If I write x equals 4, x equals 6, x equals... No, they wouldn't give you it correct now. I don't think you're not allowed to like guess to an extent. So my ratio at the moment is 1,882,384, and that's to 686,000. Now this might look really complicated, but if I look at the answer, the right hand side should just equal 1. So I know that I'm dividing, to go from here to here, I divide by 686,000. So on this side, I'm also going to divide by 686,000. Okay? So I take this and I divide by, which is 2.744. And it says to give my answers correct to 3 significant figures, so m is just going to equal 2.74. I'm glad I could do your homework for you. You should feel smart. This is a hard question, I'm not going to lie. This is very different. I've never seen something like this before. Yeah, exactly. I've never seen something like this, so this is really interesting. I might make a note to myself to like do a method doing that. That's really fun. It's actually relatively short for 5 marks, but it's difficult, which is what I like. And you'll find that in A-level maths if you decide to do A-level maths. Some of the questions are really short, but they're hard, and you get loads of marks for them, which is fun. So you earn a lot for like not much time. I genuinely cannot believe I found that. I did accept myself. I started doing random things and I thought, that's okay. To be like, you guys are like at a stage where you're going to experience like new maths stuff and you're going to make mistakes. Like I've made 1,000,001 mistakes, so don't worry about it. It's always easier once you kind of know how to get there, if that makes sense. So I really do like that question. That's a good question. Okay. We overran by quite a bit, but especially like these that stump me. Yeah, that's the problem. It doesn't really tell you what to do. If you look at the information and you jump straight to here, you have no idea what you're meant to do, right? But yeah, I completely agree with you. You're very welcome, Evie. Maybe that was a question that... Actually, no, that wouldn't have, actually. But yeah, that was really interesting. You know what? We should go through some of those practice papers. Because if they have questions like this in them, that could be quite fun. Maybe that's what we do for the next few weeks after stats. We do stats next week and then we just do a bunch of those. That might be useful. You're very welcome, Bucket. Thank you for bringing this question up. This is actually a really fun question. Very interesting. Yeah, I had no idea. You too, Evie. Have a good evening. I might use those in future, Bucket, so thank you for bringing them to my attention. But yeah, I hope you guys have a good evening. We overran a little bit. Yeah, so with GCSE, which I'm assuming you are, every Tuesday at 6 p.m. UK time is when we do these. And I'm doing it every single Tuesday right up until the last exam, in case you're interested in, asking any questions. You too. And yes, I'm praying for you, Evie, don't worry. I believe. Okay? But yeah, enjoy the rest of your week. Enjoy the strike day you have on Thursday, assuming you're not going in. Get some good work done. And yeah, I'll see you next week. So again, Tuesdays, 6 p.m. every week. But yeah. Have a good evening, guys.